Hey guys, thanks for coming in for day 2 of online learning. Kind of weird, but we're getting used to it. So yesterday we were talking about quadrilaterals and interior and exterior angles. So today we're going to recognize and apply properties of the sides and angles of parallelograms, and then also use those properties of diagonals of parallelograms. So we'll talk a bit about that. Some new vocabulary is a parallelogram. You guys know what that is, but we really are going to be heavy on the definition of it so that we can use some properties, and we're going to use that to prove all sorts of stuff. So the definition is a quadrilateral with both pairs of opposite sides being parallel. So we can use the definition of a parallelogram to prove that those opposite sides are parallel. So here's a couple different properties. If this is too small, it's also in your textbook. Take a look at it. This is stuff that you're probably going to want to write down. So the theorem 3.6 is saying if a quadrilateral is a parallelogram, okay, when we say that, we know that the opposite sides are parallel. They're also going to be congruent. Okay, so that's what 3.6 is saying. So if we have JM and KL being parallel, then also ML and JK being parallel, these two opposite sides will be congruent, and these two opposite sides will be congruent. Okay? 6.4 says if a quadrilateral is a parallelogram, then its opposite angles are congruent. So again, we have this J and L, those angles are congruent. K and M, those angles are congruent. Notice that they're not all congruent to each other, so we have to be careful about making the double congruence marks and the single congruence marks to kind of determine that these different pairs are congruent to each other, but the pairs aren't congruent. Okay? 6.5, if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. Okay, throwback, kind of try to remember what consecutive means. Consecutive is if we have x and x here, okay? And that last one we proved that those are congruent. So y and y are congruent, x and x are congruent. If we take the measure of x and the measure of y, add them together, they're going to equal 180 degrees. That's what that consecutive angles theorem that we talked about a while ago, that's what that's saying. Okay, 6.6, if a parallelogram has one right angle, then it has 4 right angles. And that one is kind of silly, but we got to talk about it. You know, if angle J here is a right angle, well, using these, L will also be a right angle, but then since the consecutive angles add up to 180, 180 minus 90 is also 90, so all of them will be right angles. And notice that this is a rectangle. Okay. So here's a proof for 6.4. I'm not going to spend a lot of time on it, but we'll kind of talk about it a little bit. So we're given that parallelogram FGHJ, and we have to prove that angle F is congruent to angle H and angle J is congruent to angle G. Okay, so we're given that this is a parallelogram. Okay, now by the definition of a parallelogram, those opposite sides will be parallel. So we can mark those in. So those opposite sides are parallel, and I'll do a little double over here to show that those two are parallel to each other. Now, since F and J are supplementary, J and H are supplementary, and H and G are supplementary, okay, they're all being cut by a transversal, so we can use that. And then, boom, supplements of the same angles are congruent, so F and H are congruent, and J and G are congruent. Okay, so here's a little bit of a real-world situation here. So in construction, so we're given parallelogram ABCD. ABCD, here we go. Suppose that the measure of angle B is 32, CD is 80 inches, and BC is 15 inches. We have to find AD. So first, I'm just going to go in, fill the stuff in that they gave us to match our diagram. So we have the measure of angle B is 32, so I'm just going to do a little arrow and say this is 32 degrees. CD, it gives us that that's 80 inches, so I'm just going to say 80 right here. Okay, and then BC is 15 inches, so I'm going to write 15 right there. Okay, if I have to find AD, what do I know? This is where I kind of pull from those properties that we talked about. If BC is 15, well, its opposite side is congruent, so AD would also be 15, right? There we go. Okay, now we have the same diagram. I lost my markings, but that's okay. Now we have to find the measure of angle C. Okay, well, the measure of angle B was 32. Now, what do we know about the relationship between angle B and angle C? They have to add up to 180. So if I take 180 minus 32, we get 148. So the measure of angle C is 148. Okay, same diagram, one last example. Now we have to find the measure of angle D. And this one's kind of easier than the last one because we know that the opposite angles are congruent. So if the measure of angle B is 32, then the measure of angle D also will be. So here we got really short 2-column proof, giving a statement, giving a reason. Okay, so here's to check your progress. You guys can pause your video to kind of think about it. Okay, ABCD is a parallelogram. Find AB. Well, if this is a parallelogram, I could kind of go through and fill out a lot of things. But if we're trying to find AB, I might want to use that opposite side. So if this opposite side is 30, then AB would also be 30. Okay. Okay, same diagram. Still a parallelogram. Now we have to find the measure of angle C. So pause your video, think about this for a second. Okay, to find the measure of angle C, there's kind of two different things that we could do. If we were given B or D, we could subtract that from 180 to find what the measure of angle C is, but we don't have those. But we do have its opposite angle, which it's congruent to. So the measure of angle C is 36. Okay, one last one. Now we have to find the measure of angle D. Well, we already found C because it's congruent to A. So like I said, take 180, subtract 36, and that'll give us the measure of angle D being 144. This is where I'd ask how you guys are doing, and you guys would nod your head, so nod your head at home. Okay, so here's some stuff with diagonals, okay? Theorem 6.7 and 6.8 are talking about the diagonals. So 6.7 says, if a quadrilateral is a parallelogram, then its diagonals bisect each other. What does it mean to bisect each other? Maybe we should remember that. I think they go through their midpoints. Okay. And 6.8 says, if a quadrilateral is a parallelogram, then each diagonal separates the parallelogram into two congruent triangles. And that kind of seems silly to be a theorem, because if we have this parallelogram, we connect two of the angles with the diagonal. Of course, we're going to have two triangles. Okay, so let's apply some of this stuff. So it says, if WXYZ is a parallelogram, we have to find the value of R. There's a lot of stuff going on here, so first we have to find where R is. So here's R. Alright. How are we going to find what that value of R is? We're going to use those properties of the parallelogram, look at its opposite side. We know that those are parallel and congruent. So I would say 4R equals 18, because those two sides are going to be congruent. Okay, divide 18 by 4. Let's go to the next one. Oops. Boom, we get 4.5. Oops. Okay. All right, so now we're finding the value of S. Again, first we got to find where S is. Okay, here's S. All right, now we got to think about, how am I going to know how to find that? Okay. We're going to say that this angle, or sorry, not an angle, it's a segment. This segment will be congruent to this segment, because since they're being bisected at the midpoint, X to this point is congruent to Z to that point, so we can set them equal to each other. Okay, do a little algebra. We find that s equals 3. Not too bad. Okay, another one here. Now we have to find the value of t. Again, where's t? T's right here. And now t is talking about an angle, but notice it's not all of angle W, it's just a little portion of it. So how are we going to know what to set it equal to or what to add it to? Okay, this diagonal cuts the whole parallelogram into two different triangles. And since we know that the opposite sides are parallel, we can kind of use some congruent stuffs. So since they're congruent, we can use the corresponding parts of congruent triangles are congruent to prove that some different angles are equal. So we have angle YWX. So YWX, that's our 2t up here. And that's congruent to WYZ. WYZ. Nope, sorry. WYZ over here. So it looks like we're going to set 2t equal to 18 and solve that for t. So then t equals 9. Okay? So now here's a couple for you guys to try. Now we have to find the value of x. So pause your video, think about it for a little while. Okay, so I'm finding now, I have an x over here, but I also have another x. I have another x right there. Okay, and these arrows are pointing to the segments here. And I think that those segments are congruent because these lines are bisecting each other. So right over here, I'm just going to show the work. So I'm going to take 4x plus 12 equals 6x plus 2. Okay, like you guys did on a scratch piece of paper in your head. A little bit of algebra. We're going to subtract the 4x, subtract the 2, so we get 10 equals 2x. X equals 5. Is that what you guys got? If you got that, take a Jolly Rancher. Okay, here's another one. Now we're finding the value of p. Where's p? Why don't you guys take a second to solve this? Okay, p is right here, talking about one of the sides of the parallelograms. I'm going to look at the opposite side, this 22. These opposite sides are congruent, set them equal to each other. We get p equals 11. Okay, one last one, finding the value of k. Right, like in that last example that I walked you guys through. Here's k, talking about this little part of the angle. We're going to set it equal to this 25. Okay, so over here I'll show my work. I have 3k plus 4 equals 25. Okay, I'm going to do some solving here. Subtract the 4 over, so I get 3k equals 21. So k should equal 7. You guys get that? Great. Okay, so here's another example. We're using some coordinates. So we're given parallelogram MNPR. Okay, so I really want you guys to draw a little diagram because that's really going to help you. So I'm just going to draw a parallelogram. All right, pretend that that's perfect. Okay, remember that when we're labeling these polygons, they go in order. So I'm going to start with M up here, N here, P here, and R here. Okay, and we're given these vertices. We have to find the point at where the diagonals are intersecting. Well, we know that they bisect each other, so we have to find the midpoint of one of these. So just for fun, I'm going to draw in the diagonals. Okay, and this point is what we're trying to find, that black dot. Okay, so we're going to use the midpoint theorem here. And notice that we're finding the midpoint of MP or RN. Oops, the words are right on top of that. So you have to find the midpoint. So we're taking the point of M and the point of P, plugging it into the midpoint formula, solving it a little bit, and we get 0.12. Now, do you guys think that if we use the points of R and N, we would find that same point? Should be nodding your heads. We absolutely would. And I'll walk you through that one in the next example. So the coordinates of the intersection of the diagonals is 1, 2. Okay, so here's one for you guys to try. Pause the video, draw yourself a little picture, and then try to figure it out. Okay, so I'm going to draw a parallelogram. Oh, that wasn't good. Okay, we got to label it correctly, right? So I'm going to start up here with L, over here with M, and that's an M, sorry, and O. Okay, so now we're finding the midpoint of either LN or OM. So we're finding that point right there. Now if we take the points of L and N, plug them into the midpoint theorem, or O and M, we should find that our point is 1/2, 1. Okay. All right, now here's a little proof. We're going to prove, oh no. Okay, it's given that we have a parallelogram ABCD, and it tells us that AC and BD, the diagonals, and then the point of the intersection is P. Something's goofy here. Okay, so we have to prove that AC and BD bisect each other. Okay, we're only given that they're diagonals. We're just proving that they do bisect each other right in that midpoint of each of those. Okay, so next page, here's that same diagram. So first part of any proof is always just stating what's given. So we'll go ahead and do that. It's given that it's a parallelogram, so we know that the opposite sides are parallel, okay, by the definition. AC and BD are diagonals, therefore AB, like I said, parallel to DC, and AC is a transversal. Okay, next, by alternate interior angles, using that definition with the parallel lines, we know that angle BAC is congruent to DCA, and ABD is congruent to CDB. So let me mark those in with the congruence. So we have BAC, this little guy, is congruent to DCA, that guy. Okay, now notice that I'm switching gears here to a different pair of congruent angles, so now I have to use that double congruence mark. So I have ABD, this one is congruent to CDB, this one. And that's by the alternate interior angles theorem. Okay. Now we know that AB and DC are congruent because the opposite sides of the parallelogram are congruent. That was one of those properties that we learned. So I'll go in and mark those as congruent. AB is congruent to DC. Now some of you might be thinking, hey, looks like we're proving two triangles to be congruent. And we absolutely are. Okay? So those two triangles are congruent by angle, side, angle. We got the two angles of both and a side in between those two. So by the corresponding parts of congruence triangles being congruent, BP is congruent to DP, right? And then AP is congruent to CP. So I'll do a triple mark here. And what we were trying to prove is that P is the intersection where they bisect. So therefore, AC and BD do bisect each other. Okay? Now you guys don't have to write out the whole proof, but they're giving us some information which one of these things is going to be relevant to proving that angle LNO right here is congruent to angle NLM, this one. Okay, so pause your video, think about it for a second. Okay, option A is telling us LO is congruent to MN. LO is congruent to MN. It is, but I don't know if that's necessarily relevant to proving this. tells us that LM is parallel to NO. They absolutely are. That might be an option. And it says OQ is congruent to QM. OQ to QM. Okay. Or Q is the midpoint of LN. Honestly, the most relevant thing here is saying that these two lines are parallel, and that's in the definition of the parallelogram. So, couple things. You should really write this down. This is just kind of summarizing everything that we learned today with the parallelogram. So, if a quadrilateral is a parallelogram, these properties are true. The opposite sides are congruent. The opposite sides are parallel, and that just comes from the definition. The opposite angles are congruent. That was one of the properties. The consecutive angles are supplementary. And the diagonals bisect each other. So this is stuff that we will be using a lot, so you really should write this stuff down. Okay, here's our assignment. It's page 407, 9 through 43. You can skip 25 and 39. There's some proofs that honestly we think you guys would have a lot of questions on, so we're just skipping them all together. All right, hopefully that wasn't too bad. Tune back in for our next section because it's a double day. Thanks, guys.